Welcome. In this video I'm going to show you how you can perform a post-hoc residual analysis after a goodness of fit test using binary test or residual test using Python and my stikpetP library. I'm using Jupyter Notebook, but this should run in any studio where you have Python installed. This is a test that could be used after you've performed the goodness of fit test, and unlike pairwise test, this is not going to compare each category with the other categories, but it's actually going to compare each category with its expected counts. To show you how this can be done, I'll need some example data, so I'll load in pandas as PD. So I can use their read CSV function and then load the general social survey data from 2012 adjusted for these example purposes. Now, I don't need all its data, I actually only need one nominal field, so I'm going to store under nominal field the marital status, which was stored as mar1. And just to give you a quick impression, 79 people, for example, selected that they were separated. Now, my library, you will need to install it via pip install and then the full link to my GitHub. And then you can import it just as any other library using import stikpetP as PS in this case. That's what I prefer to use. The function of interest is actually pH, short for post-hoc, residual goodness-of-fit, and then binary test. It actually only needs the data as its input parameter. However, you could also specify the test, and then you can either use standardized residuals, adjusted residuals, binomial test, a wall test, or a score test. You can also specify the expected counts if you have them. Otherwise, I will just assume that each category was equally likely, so it will sum up all the counts and divides by the number of categories. You can also adjust for multiple testing. The default is, I think, Bonferroni, but there are some other options if you're interested. And you can pass along any of the other arguments to the binomial, walled, or score function. So if I run this, I get actually quite a lot of output, hopefully. We get to see the category, the observed count, the expected count, in this case all equal. It's used a standardized residual z-test. On my website I explain a little bit more on and show the formulas for those. The p-value of that and the adjusted according to the method that was used, the default being Bonferroni at the moment. So usually if this one, the adjusted p-value is below a predefined threshold, usually 0.05, we would say it's significantly different. So in this case, except for never married, all of them are significantly different from the expected count. Alright, and that's basically it actually. So if, for example, you do have some expected counts, so for example these, I can enter them as a data frame, just as shown here. And then I can actually use that as my expected count, and I will get slightly different results. And here we can still see that I think all of them except for, well, actually divorced is now no longer significantly different from its expected counts, 0.8, so that's also not significant. 0.10 is also not significant. So actually only the first two seem to be significant now, married and never married. Alright, I hope this video was helpful and thank you for watching.